Hello everyone, welcome back to Math with Amala. Let's move to the grade 9 chapter 1 part 4. Here we will deal with the irrational numbers. So let's have some history. What do you mean by Pythagoras theorem? Do you have any idea? Yes, you have already covered the portion in your previous classes. So it is related to a right angle triangle and it is proposed by the famous mathematician Pythagoras, and here we considers a right angle triangle with base, altitude and hypotenuse. So the Pythagoras theorem is base square plus altitude square is equal to hypotenuse square. So the peculiarity of this right angular triangle is the base and altitude are 1. So we have to find the length of hypotenuse. So from this you have got it is 1 square plus 1 square is equal to 2 and hypotenuse square is equal to 2, that is hypotenuse which is equal to square root of 2. Do you know the value of square root 2? Let's see. Do you know the value of root 3? What about root 4? It's 2. Root 5? You don't know. Root 6? Don't know. Root 7? We don't know. Root 8? We don't know. But root 9 is 3. And root 10? Also we don't know. So let's see. What are these peculiar numbers which are not coming as a perfect square root? Or this 2 is not a perfect square. The radian measure pi also is not a whole number solution. So let's call these kind of numbers as irrational numbers which are not coming under any kind of rationality. Sometimes we can express them in the form of rational numbers, but it will not be correctly that number. We may be approximating that number to the required rational number. So we know the definition of rational numbers. When p by q, p and q are integers and q not equal to 0 is the definition for rational numbers. But if this is not possible or if it is not satisfied, then such kind of numbers are called irrational numbers. So in the irrational number set, you can find some values like root 2, root 3, root 5, pi, 0.10110111011110. Likewise it continues. That means it is repeating after repeating with a pattern, but we can't say it like a proper fraction. Hence in the ancient period, Pythagoras proved root 2 is irrational through his Pythagoras theorem, and also Theodorus of Cyrene also proved the same for some other numbers also, like root 3, root 5, root 6, root 7, root 10, root 11, root 12, root 13, root 14 and root 17. Root 15 and root 17. Here we can see that root 4, root 9, root 16 are not included in this list because they are having a perfect square root. They are already perfect squares. So we can say that these numbers are not included in the irrational set. Let us move to the real numbers. Let's see what are real numbers. Before that, we know that what is natural number, then whole number, then our integers, and also q. What is q? The rational numbers. I have written it r, you can change it to q. Then the irrational numbers. So there is a mother set which includes all these numbers together. So let's write those numbers once again. Which is the first one? N, natural numbers, W, whole numbers, Z, integers, Q, rationals and the irrationals. Okay, so there is a big set which includes these real numbers, but there is one more set which includes these real numbers also. That set is called complex numbers. Complex numbers which includes I value. I is actually equal to root of minus 1. Okay, so a real number means which can be either q or either rational or irrational. Okay, so a real number is either rational or irrational. That means it can be a whole number, natural number and integer. The reverse is not possible always, even though we can say these are the real numbers. Now let's do for the number line also. What do you mean by number line? It's a very simple concept that we are handling from our grade 6 onwards. So in the chapter integers, so in the number line you are having a equal separation towards the left of 0 and right of 0. Actually it is not equal separation, it is approximate separation. So 0 is the center, then you have 1 then minus 1, 2 minus 2, 3 minus 2 alternatively on the left and right of this 0. So if we take any number in between 1 by 2, it is having a point, it is having a particular place in the number line. So we can say take any real number, it should be on the number line. So every number on number line can be expressed as a unique real number. Thank you all for watching the video. Please stay tuned for the next part, which contains the next section of irrationals.